Hello. So my name is Aryan and this is my applied machine learning assignment 1. So right now first we are importing this we are importing this data set in this library. So from keras.dataset this we need to download this data set from this library. So here so for that to command we are writing this we need train images, test labels, test images and test labels, and this is the thing. So we did that and I downloaded it over here. You can see all the files are downloaded for our training and test purposes. And right now we are gonna start like our questions with. So first question is we have to tell the dimensions of these. So for that there's a function. So we can use this dot ndim gets the dimension of the image. So it's like 3D is 3 dimension and this is 1 dimension. This test image is also 3 dimension and this is 1 dimension. And here, second question is like we have to tell the lengths of train labels and test labels. So length of train label is 60,000, yeah, 60,000, and train label is also 60,000. All the same thing as what I also have. Rest. Let's do test labels. So it's 10,000. Look, test labels are 10,000 and train underscore label. So now we have to show some of train and test labels. So for that we need to like check how like tell like some. Let's pick out the sum of the labels and check are they the same or not. So let's see first. So this is the functions from 0 to 3. So it will go from 9, 0, and 0. So the three properties pick from like first dimension, like first from array, and then pick this. Like if I do this, it will be different. And there will two. This is different. Okay, let's see. Okay, so like we are showing this, and then now for the this is for train. This is training purpose, and look for the test. This is slight similar and slight different. So 9 is same, but like 2 and 1 because it's test. We're testing this, and then this is training for training purposes, and this is for testing purposes. So it's like similar to this one almost. That's what it's called, machine learning. And now we are trained. So we are gonna see the images which are train images file. So like we're gonna see like image. So 00 is like these are the color numbers, the color shades, 22, 88. These are all the shades, and this is the image in binary form. It's like 2028 by 28 pixel image, which is shown like this. This is data of the image, and now you can see how the actual image looks. The actual image looks like this when you're gonna do. So I put the this in image variable and then import the library matplotlib and then plt.image show img. So this is the image. So now sixth question: what is the label for index 5? Train label and looking up the above list. What does it means? So training label for 5 means 2, which means it's pullover. Like you can see it's written over there. This is like you can see it's a pullover jacket, sweatshirt. So that's why it's 2. 2 means pullover jacket, sweatshirt. Yes. And then now for test image. You can see the test image is almost similar to the train image, almost similar, but like I'm showing it in black and white. So this way you can see the image in black and white. If I just remove this, it will show it. This is what I found on Stack Overflow. It's pretty cool. Wait, I, this is not okay. I didn't load that. Let me load this. I have to go up and load all of it now. I'm going to see. The came back, so it was not loaded before, and now it will work again. So if we remove this CMap PLT, it changes the image to black and white format, but actually it looks like this. If we run without that. It's kind of like X-ray vision. We don't need, I will just run this one like this. So next, now we need go to question 9. Question 9 is what is the label for index 500 and looking up the word list? What does it mean? So it's asking again, what does it means? What is the label and what does it mean? So we're gonna see. We put like this and this. What does it mean? It means it's pullover jacket. Two means again pullover sweatshirt. So that it's now we are importing sub libraries again to do the. So we have imported this TensorFlow and because there's some issue with like old version and new version, so I did this whole thing. And then 10 import model and layers from KS library. So I'm importing this KS from KS library. I'm importing this model and layers and this TensorFlow.ks from import layers. So I did all of it, and then now it asks for put define a sequential model and call it my network. So I'm defining a sequential model here and then defining it in my network. And now question dot what does the question dot reshape and the image 28 by 28 on one column 784 neurons. Used to pixel image should be 728 by 28. So this is gonna do it. So test image train image is equal to train images and what reshape we reshaping it out. It asks us to reshape. So it's like it's the book method. So like length will be 60,000 what we tested above. So 60,000 in comma 28 into 28, which is size, and did this for the image. And from the video method, we used to use flatten method. So like if you use flatten method, just do it by itself without telling like what is the layer, how much 128 by 28 will do it. So that's what I did. Up there now we are just checking. So we need to check 784 nearest because it's not showing anything. It's run, it doesn't show anything. So if you just go train images dot shape, it will show us the tensor shape of the image. So it's like 60,784 neurons record to one column with 784 neurons. It's not code. So now again. So what is the 13th question? Let's see what is the 13th question. Also normalize image by dividing image by 255. Use the two method one from book one for video. So again two methods. Let's do first book one. So it's again same. Use the type. What type? Like we know float to by 250 divide it will get us. And now why it's 200 twice. Okay, so here KRS to import utils and this is the train image and train image is equal to utils dot normalize train underscore images ass-1. So this is the video method which I found in the video. So it's like no, it's like using this from this library we import utils and then we normalize the train image from at ass-1 and test images dot ass-1 and did this. So this is train image 0. You can see now again and again. So now let's what's the 14th question? Add another linear layer that has 128 neurons use ReLU activation. No, 512 neurons use ReLU activation option. So this is the ReLU activation. We wrote down like dense. This is we need to add layer. So dense 512 activation need ReLU and then this is dimension 784 neurons was before now it will not be input them. So this was it. And now what is the newer version? It's 30 rounds should be 128. Okay, so it's 128 now. 128 execution value, and then this will be like we need 10 neuron dense layer, softmax activation. All done. Now we need to compile Adam. So this is optimizer. So we need to compile like my network. So my network dot compile optimizer, which we need this optimizer Adam loss cell matrix, and we did these two steps over here. So basically it is like compiling and then optimizing the image from my network model, which is a loss sequential. So and then this is the matrix, so it will be accuracy. So like it will give us like accuracy. So loss, it will check the loss what is the difference between the outcome and say what is that given and what should be the output and the difference between output and what is the real value should be. And so we are using these optimizers. First we use the Adam optimizer. Now in this we use the RMS proper optimizer and its category cross entropy written here. So it's basically given us. So now how do you compare the fashion means with the what we learned from the in the class using unit and what we can infer from the differences in the accuracy? What could be the reason for that?